Okay, so first here one node and the second node and third node, and this is the reference node. Okay, first, second, third, and reference node. Here n minus 1 equations we will get. Okay, so n minus 1, 2, 3, 4, one reference node. Na? That's why n minus 1 equations we will get from this circuit. N minus 1 means, yeah, 4 minus 1, 3 equations we will get in the form of voltages. Am I right now? So by using nodal analysis, we are finding the node voltages based on the concept of Kirchhoff current law. Understood? Nodal analysis related to Kirchhoff current law. Mesh analysis related to Kirchhoff voltage law. Okay. Mesh or loop, that is related to the KVL. But nodal analysis Kirchhoff current law. Okay. By using KCL, we have to find the voltages, node voltages. It's clear. By using KCL equations, we have to find the node voltages. So we will get equations in the form of voltages. Okay, what is the voltage here across the V1? V1 by R1. This is called I1. V1 by R1, V1 minus V2 by R2. Okay, and plus 2 is equal to 0. This is the equation across this V1. Understood? Across this node, what is the equation? V1 by R1, V1 minus V2 by R2 plus 2. Am I right or not? Understood? At this node, what is the equation here? V1 by R1 and V1 minus V2 by R2 and plus 2 is equal to 0. Here, V1 is higher in magnitude. That's why the current always leaving from V1. So we have to take the plus, notation plus. Otherwise, minus. Understood? Similarly, V2. Okay. Here, we have to assume the junction node higher voltages, magnitude of the higher compared to V1 and compared to V3. So assume V2 is higher in magnitude. So then equation will be V2 minus V1 divided by R2, V2 by R4, V2 minus V3 by R3 is equal to 0. That's it. Understood? Irrespective of the current direction. Understood? If it is current direction, if it is magnitude here V2 is greater than V1, the current is flowing in this direction. That's called I2 is negative. Understood? Similarly, to find the equation at V3, so assume V3 as higher in magnitude, then the equation will become V3 minus V2 by R3. Then V3 divided by R5. And then current is entering, that's why minus IS is equal to 0. So you will get like these equations. 1, 2, 3 equations. Okay. Understood? I'm already explained the last class how you are getting the equations. Okay. So this is the inspection method. By looking the circuit diagram, so we have to write the matrix. Directly we have to write the matrix by looking circuit diagram. Understood? By looking the circuit diagram, so directly we are writing, we have to write, it is possible to write. Generally, try to consider here. So V1 at node 1, what is the G1 here? 1 by R1 is called G1. So the node 1 is connected to the this element and this element and this source, current source. That's why this node 1, 1, 1, A11, A12, A13, like that. 1, 1 means it's connected in between these two and this and here. That's why G1 this connected to the R1 and R2. That's why 1 by R1 plus 1 by R2, nothing but G1 plus G2. Okay, so 1, 1 and 1, 2. Okay, the mutual. Take minus, only one element is between these two. That's why minus G2. There is no element between these two. V1 and V3. A13 is 0. Similarly, 2, 1. 2 to 1. One element is connected. That is called R2, 1 by R2. Nothing but minus G2. It's clear. And then 2 to, what are the elements? This terminal, this element, this element. That means G2, G4, G3. No? So then another 2, 3. No? 2, 3. So one element, R3. That's why minus G3. And then 3, 1, 0. There is no element between 3 and 1 directly. Okay. And 3, 2. 3 to only one element. No? That is called R3. That is called minus 1 by R3. That is nothing but minus G3. So then here R3 and R5. No? The two elements are connected. That's why G3 and G5. And this node 1 is connected one current source. It is leaving. That's why -2. Is entering at node 3. One current source is entering. That's why IS. Is entering plus, leaving minus. Okay. And there is no current source across node 2. At node 2, there is no current source. No? That's why 0. So by looking the circuit diagram, so we have to write matrix equations and we have to find node voltages directly. It's clear? So like this. So this is the problem. All of you read this problem. All of you take this problem. So by inspection method, you have to write the matrix form directly. So without equations, without equations, we have to write the matrix directly. Without equations, we have to write matrix like this. So first, so what is the resistance here? 2 ohms, na? 2 ohms nothing but 1/2 Siemens. That is called mho. G. G is nothing but 1/R, na? 1/2. So here also G is nothing but 1/1. So 1 Siemens. And here also convert all resistance into mhos or Siemens. Convert all resistance into mhos or Siemens. It's clear. And then this node is connected between these two. That's why 1/2 plus 1, 1 plus 1/2 like this. It's positive now. Similarly, 1 is over and 1 2 only one element. That's why mutuals are negative polarity. That's -1. Okay, and then there is no terminal between. There is no wire resistor between V1 and V3. That's why 0. It's clear. And then V1. This is related to V1 now. At node 1, we are finding. And then current leaving -2, entering positive. And similarly, at node 2, 2 1, only one, one Siemens, one more, and is mutual -1. And 2 2, 1, 1/4, 1/3. And 2 3, -1/3. And 3 1, there is no element between these two. 0. Understood? 3 2, 1/3. Only one diagonal, only one element, mutual element. And then 3 3. So this element and this element. 1/3 plus 1/2. It's clear. V1, V2. This is the voltage matrix. And in the current matrix, leaving, there's a -2, entering 1. And there is no element, there is no current source across 2. That's why 0. Understood? So in mesh analysis, by using KVL concept, we have to find the loop equations, loop currents. Okay. In node analysis was developed by applying KCL at each non-reference node. Am I right? Node analysis related to the KCL. And loop analysis is developed by applying KVL around loops in the circuit. Understood? Nothing is a simple concept. Node analysis, KCL. At node, we are finding the, we have to find the equations. But in loop analysis, using KVL. That means in a loop, we have to find the voltage drops. Sum of the all voltage drops is equal to 0. Understood? Mesh analysis is another general method that is almost as powerful as node analysis. I'm already told, no? Compared to node analysis, mesh analysis is a very powerful technique. By using this, we have to find the mesh currents and the loop current, that is called loop currents easily. Okay. Any complicated networks also is easy possible to find the equations compared to node analysis. Node analysis equations are more, but mesh analysis also more, but mesh analysis will get easy equations, easily equations. Node analysis was developed by using KCL and loop analysis, KVL. Okay. Loop analysis results in a system of linear equations which must be solved for unknown currents. Okay. In node analysis, we will get to the equations in the form of voltage. No? That means V1, V2, V3. We have to find node voltages in node analysis. Mesh analysis, we have to find the current, loop currents. It's clear. Understood? Then, so one of the example. Okay, so these are the two voltage sources in the circuit. The output voltage V of the circuit is proportional to the sum of the two input voltages V1 and V2 across this. So this circuit could be useful in audio applications or in instrumentation. Okay. Some audio applications, these circuits are generally used. The output of the circuit would be probably be connected to an amplifier. Okay. Then is one of the simple circuit practically. So we are using like this. We have to use like this. Okay, mesh analysis. These are the different types of steps in mesh analysis. All of you write. Everyone write. These are the different types of steps in mesh analysis. First one, identify mesh. Okay, step one. So what we have to do? First, we have to identify the meshes. That's called loops. First, we have to identify the loops. It's clear. So like this, identifying the meshes. So mesh one and mesh two. These are the two different types of meshes. Okay, first identify meshes. That is called loops. Second, assign a current to each mesh. First one, identify mesh. All of you write fast. First one, identify mesh or loops. This is called mesh. It's a closed path. Okay. If it is, for example, if it is there is no wire between here and here. Okay. If there is no wire between this, there is not a mesh. It's not a closed path. No? Okay. If there is no wire between these two, if there is no connection between these two. Okay. If it is compulsory, closed circuit is called as a mesh. Compulsory closed circuit is called as a mesh. Okay. It's closed circuit. No? It's closed circuit with voltage source and a resistor and this resistor. That's why it's called meshes or loops. And then second one, what we have to do? Assign a current to each mesh. Understood? First one, identify mesh or loops. Okay, first identified mesh 1 and mesh 2. Okay, and then assign a current to each mesh. So like this, I1 and I2. So the directions are not fixed, as your wish. So if you want to assume in this direction, anti-clockwise direction, as your wish. Okay, understood? Understood? So you want to arrow in this direction also, it's possible. Anti-clockwise direction is also possible. If you want to, so this is clockwise direction, this is anti-clockwise direction, as your wish. Okay. So you will get the same equations, same results if you are assumed in opposite direction. First one, identify meshes, completed. So like this. And the second one, assign a current to each mesh. So like this. Each mesh, currents are assigned, I1 and I2. Understood? And third one, apply KVL around each mesh to get an equation in terms of the mesh currents. Apply KVL. KVL, Kirchhoff voltage law, apply Kirchhoff voltage law around each mesh to get an equation in terms of the mesh currents. Understood? That is the third one, third step. So like this, voltages from mesh currents. If this resistor is related to the only one mesh, understood? Is not connected between the two meshes. Understood? If it is not, this resistor is not connected between two meshes like this. Separate. Okay, this is the two meshes. No? This resistor is connected between two meshes. Okay, but this resistor is only connected. Is belongs to only first mesh, first loop only. Okay, so that's why the current I1. So what is the voltage drop here? VR is equal to I1 into R. VR is equal to I1 into R. Voltage drop. Current entering is like this now. That's why you are positive and negative, and VR is equal to I1 into R. So that's it. And then the current is clockwise direction, one mesh, and this current is anti-clockwise direction, one mesh. Okay. Here, flag current is here, mesh loop 1 current is downwards direction, here current upwards direction. That is two current directions are opposite. Na? Current directions here downwards direction, current direction is upward direction. Two current directions are opposite. Okay, this current direction is I1 and this current direction is I2. Opposite. If I1 is greater than I2, then VR is equal to positive. Okay, if I1 magnitude current is greater than, then resultant current is nothing but I1 minus I2. That is like this manner. Yeah, current is entering positive, leaving minus. Na? That's why entering positive, leaving minus. If it is current plus minus is nothing but current entering positive, leaving minus. Try to remember. Okay, at passive element, current is always entering at positive, leaving it negative. But active element opposite. Understood? Current entering at positive and current leaving it negative. So that's why the current is like this manner. That means this current direction, main current direction, I1 current direction, same. I1 in this direction, hmm? And this main current direction same. That's why I1 is higher in magnitude, I1 minus I2 into R. So like this we will get equations. Okay, then apply the loop equations, KVL around the loop and this around this loop. Okay, try to consider here. So in this first we have to start at source terminal. So first entering minus, na? Entering minus. That's why minus V1. Remember this like this. You can easily understand every problem, each and every problem you can easily understand. Entering minus, na? So that's why minus V1. Here entering plus here. Current flowing in this direction means here plus and minus, na? Plus I1 into 1K. I1 into 1K. And then coming to here. So we are finding the equation in loop 1. That's why try to assume I1 is higher in magnitude. Understood? I1 is higher in magnitude. Try to concentrate here. I1 is higher in magnitude. That's why I1 is current is downward direction. Okay. I1 direction, I1 current is downward direction. So that means resultant current. What is the resultant current? Is current is upward direction. It's downward direction. That's why I1 minus I2 is a resultant current downward direction because of I1 is higher in magnitude. We are assumed I1 is higher in magnitude. Okay, in mesh 1. So that's why I1 minus I2 into 1K is equal to 0. That's it. Simplify these equations, you will get like this. And then mesh 2, then this equation. So here entering this known, assume here I2 is higher in magnitude. In previous case, I1 is higher in magnitude current. Here I2 is higher in magnitude. That's why I2 minus this current downwards, no? This current upwards across this element. Understood? Otherwise, you have to start. You want to start source entering positive plus V2. Okay, plus V2 entering source, na? Plus V2, and then at resistor you're entering positive. That's why I2 minus I1 into 1K. I2 minus I1 into 1K. Then I2 into 1K. That's it. Is equal to 0. Understood? Nothing is a simple concept. Okay. So by first meshes, then current, then equations. That's it. Solve the resulting system of linear equations. So I1, I2, I3, I1, I2. We will get equations in the form of voltages. I1, I2, source voltage. Okay, we'll get equations like this. So I1, 1, 1, 1, 1, 1 kilo ohm, 1 kilo ohm. Coefficients. So we'll get like these equations. First, complete first. First identify mesh. So like this. First
We
identify.
couldn't. Okay.
First identify like this. Okay, mesh 1 and mesh 2. It's clear. Like this, by identifying the meshes, so later what we have to do? Assign a mesh currents. After that, assign a current to each mesh. So like this, I1 and I2. This is called step 2. Understood? Step 1, identify meshes, mesh or loops. Identify mesh or loops. Second step, assign a current to each mesh. So like this. If it is another element is connected, that is called another mesh, I3. And then third one, apply KVL around each mesh to get an equation in terms of the mesh currents. So okay, so like this, based on this concept, the current is entering is positive, leaving minus. Here, current entering is positive, leaving minus. That's why this current main current direction is like this. Na? That's why I1 is higher in magnitude, I1 minus I2. Then into R. I1 current direction with our main current direction same. Okay, that means I1 is magnitude polarity. I1 magnitude is I. For example, if 4 amps is this called 2 amps. 4 minus 2, you will get positive. Okay, otherwise the negative. So by applying a KVL in mesh 1, you will get equation. So entering minus V1 plus 1k into I1. Here current I1 is magnitude I. That's why I1 minus I2 into 1k is equal to 0. Understood? If you want to apply in mesh in this mesh 2 loop equations, entering is positive, no? That's why plus V2, and entering at resistor positive, negative. No? That's why I2 minus I1. So you are applying a mesh in 2 na? That's why I2 is magnitude I, current magnitude of the I2 is I. That's why I2 minus I1, then only here positive and negative. I2 minus I1 into 1k. That is called voltage. Then 1k into I2 is equal to 0. Then they will get to like this equations. Solve the resulting system of linear equations. So by using I1 and I2, you will get it. So V1, V2 now here. Then by using MATLAB, then one of the software is there. So 7, 4, they are taken 7, 4. 7, 4. 7 minus 4. V1 voltage 7 and minus 4. And they are I1 is equal to 3.33. Example. I2 is equal to minus 0. Okay. So like that, so we are getting the results like this. So then another example, all of you draw the circuit diagram.